All right. Okay, so we're going to dive into this stuff here. So just a couple of, I always like to kind of throw in a couple of fun facts about whatever new organ system or thing we're talking about. So just throwing those in here. So interestingly, the skin completely regenerates itself about every 20. Okay, so that means you have a full new skin because those cells are proliferating so rapidly every 27 days. About every hour, we about 600,000 skin cells fall off of us, right? And so that idea there that I mentioned before about the dust, a lot of the dust in our house is skin cells. We're losing just a ton of skin cells constantly. And that's about 1.5 pounds of tissue per year that comes off of us. Yeah, and then somebody who lives to be 70 will shed about 105 pounds of skin. So that's a lot of skin, a lot of tissue coming off of us all the time. Right? Okay, all right, so let's go ahead and discuss these barriers a little bit, okay? So go ahead and discuss kind of the different barriers with the people on your team. Okay, go through notes, see what the names of those different barriers are, and then you can hop over to this question, and then this is when I'll have you answer kind of with your fingers here in a second, okay? So go ahead and start talking about that. So what makes up each of those barriers? Talk about that. What are their names?
Biological is oh my god, the linger hand is a macrophage.
Oh, those printed out full page, huh? I didn't mean to do that one.
So I don't know what
was yours. I turned it off a long time ago, so yeah,
So I'll just
should
turn
be
it off
should
on
be
you.
fine. Yeah.
It scared me. I was like,
Yeah.
oh no.
All right, go ahead and hold up your answers for this. 2 hands most likely here, or whatever, however many you got. Okay. All right. Yes, most people are saying 1 and 5, so A and E. Okay, so the temperature barrier, we don't have a temperature barrier. But one of the functions of the skin is to help us regulate temperature, right? But it's just not one of the barriers, but it is one of the functions, okay? Same thing with the moisture barrier. Really important function that the skin has. It keeps moisture in, but it also keeps moisture out, okay? But again, it's just not considered one of these barriers that the book talked about. So, okay, any questions on those? So yeah, temperature and moisture barrier, correct there. Okay. Let's go to this one. So discuss the different types of things that make up the biological barrier. And what is it protecting you against? Okay. And then answer this question here on this slide.
Yeah.
All right, what do we got here? Hold up the ones that are true. Okay. Got most people saying 3 and 4. I see some 2s up there too. Yeah, so 3 and 4 would be the Langerhans cells and the macrophages. Okay, so which components make up that biological barrier? And the key here is it's the things that make up the biological barrier are cells, right? So the cells that are helping us do things. Yeah, we have other things that destroy things that are alive, like those defensins and other things, but those aren't cells themselves. The things that make up the biological barrier are cells. So where do we find the Langerhans cells? In which part of the skin? Epidermis, and then the macrophages? The dermis, good. Okay, great. Okay, let's do this one.
You show through like this. Oh, sorry. Read like this. This means young life in my culture.
My culture.
So much.
All right, what do you guys got? Hold them up. Okay, hold it up. Yeah. Okay. Yeah, so everybody's saying the dermis. The dermis is packed full of blood vessels. Okay, lots and lots of blood vessels in the dermis. We can, when we start exercising, actually, we can, before we get too hot, we can actually take some of that blood out of the dermis and kind of send it back to the rest of our circulation. So we got more blood to feed our hearts and to give us more cardiac output. But then once we start getting too hot, we send that blood back to the dermis to help us cool down too. So it has lots of functions in that way. Okay. All right. So discuss with your team the cell types you find in each layer of the skin and their functions, and then go ahead and answer this question on the next slide.
So
We should do karaoke. I just
Glad the character is up front, so you can entertain me. All right, what do we got here? Go ahead, hold up your answers. Okay. Most people are saying 3 and 4. Okay, so fibroblasts for sure, and then macrophages. We had already said that one. Let's walk through each of these. What they do for us. What do melanocytes do? Produce melanin. Okay, they have these little extensions that come out and they poke into those keratinocytes as they're growing, and just add little pigment protein to those keratinocytes to change the color of them. Okay, keratinocytes. What's their main role? Yeah, they make up the epidermis pretty much, right? So they do a lot of those things, the protective functions, the moisture functions, a lot of those things, anything that has to do with them just being a barrier. That's really the ones that make up our barrier. Okay, what do fibroblasts do? Yeah, they make collagen, they make protein, right? They're the ones that are sending out most of that protein that makes up the connective tissue layer in the dermis. Okay, and the macrophages, we already talked about what they do. What do Merkel cells do? Yeah, they're touch receptors. So this is that innervation part of the epidermis. This is partially why we can feel when something touches our epidermis very lightly. Okay, Any questions on those? Okay, all right, quick one here. Layers of the skin. All right, go ahead and hold it up whenever you're ready. Hold it up nice and high. Yeah, pretty much everybody's saying C there. So the basal layer of the epidermis. It's also known as the stratum basal. That wasn't in the notes, but that was in the textbook. It's that basal layer. Good. Okay. That makes sense, right? The layer at the very bottom is the one that's closest to the blood supply. So it's constantly dividing, actively dividing, sending new cells up to just continually be replacing the cells up above. Okay. All right, blisters.
I definitely know the water blister is epidermis.
All right, what do you guys think? Hold them up. What do you think? What do you think? Nice and high with pride. Okay, thank you. All right. 4, 5. Most people are saying 4 and 5. So D and E. Okay, so separation of the layers of the dermis causes blood blisters. Absolutely, because there's blood in the dermis. Okay. So if we separate two parts of it, then it kind of just makes some extra space for blood to fill in. Right. And then that just kind of stretches the layers out above it and fills that little space with some blood. Okay. And then E, separation of the layers of the epidermis causes water blisters. That one's true as well. So when when two layers of the epidermis kind of open up, again, it just makes like a little hole in there, and then that hole is going to fill in with water or with plasma, really, and then that's going to just kind of fill in and cause that clear type of blister like that. Okay, and this one's like a little bit questionable, separation of the dermis and the epidermis. It's not fully sure like which way that's going to go. That probably could produce a blood blister if it kind of scraped the top of the dermis when it did it, or it could be a water blister as well. So don't worry too much about if you were trying to struggle on that one. Yeah, it's kind of could go either way. Yeah, Olivia. Yeah, I mean, it usually just takes more force to create a blood blister because it's just, but it also just has to do with kind of what's causing it too. So there's a lot more pressure that it can kind of just push a little bit deeper. Whereas, but if it's just more of like a light, something that's kind of rubbing lightly on your skin over and over again, then that would most likely, maybe cause the water blister instead. So it's, yeah, it has to do with just like the depth and the amount of pressure that's put on the skin usually. Yeah, and you're not technically supposed to pop blisters because it's just opening up yourself for infection. But sometimes they're just in the way, right, of doing what you need to do. And so sometimes you need to pop them. One of the best ways to pop them is to get a needle and kind of put it in like over here and get under the skin. And then you can kind of squeeze this fluid out and it kind of shoot out this way. That way you kind of make like a little tunnel just through the top layer of your skin, and you can get that fluid out without actually just opening up the skin that's kind of going to be raw and fresh. So yeah. All right. Okay. All right, let's do this one. Go ahead. Talk through those 3 questions.
I always don't what because I thought they were perfect,
I can't tell.
Ways.
So then what's this? This whole thing is epithelial? Okay.
All right, so why don't on your hands, you hold up the one that's the answer to number 2, question number 2. We'll hold that one up, whichever letter you answer for number 2. Number 2 is 2. Everybody's saying 2. Okay. All right. So C would be what? Yeah. So that's our epidermis. That one's going to be made up of primarily keratinocytes. And there is this kind of division here that makes this image a little bit confusing. That's kind of just showing this division between the cells that are kind of alive and still dividing towards the bottom and still have nuclei versus the ones up above that are pretty much just flattened out keratinocytes. And so then let's just go by the question number. Question number 1. What letter for that one? Yeah. So that's the deepest layer, the dense irregular connective tissue. But what is that layer of the dermis called? Reticular layer. Yeah. So don't get confused by which type of connective tissue that is. It's not reticular connective tissue. It's dense irregular connective tissue. And that's just called the reticular layer of the dermis. Okay. And then obviously B for there. Okay. Any questions on that one? Go ahead.
Is there no clear division between the two? Or is it just where they're like-
Yeah, this image doesn't show a super clear division. Other images, you can see a little bit more of a division where it gets a lot wavier in the bottom part, but yeah. Okay, we're gonna do just a quick, just some quiz, a couple quiz questions here on this epithelial tissue, okay? So go ahead, talk through this one. Just give you a few seconds, and when you're ready.
Has goblet cells.
All right, hold it up when you're ready for this first one. Go ahead, hold it up. Hold up your answer. Okay, good. Everybody's saying 3, so stratified squamous. Good. All right, give you another 30 seconds or so for this one.
The first one is stratified.
What's that?
The second one's deep.
Did I circle the wrong one?
I think we're just like we were on this slide and then I don't know.
Oh, yeah. Yeah, first one was stratified squamous, yeah. All right, go ahead and hold it up. What do you got here? Okay. Good, everybody's saying E, so simple columnar. Okay. What are these little cells called here? Goblet cells. And you can actually see them releasing their mucus in that image. It's kind of cool, right? Okay, go ahead. Another few seconds. Think about this one. All right, what do you guys got on this one? Hold it up when you're ready. Okay, number 2, yeah, simple cuboidal. Whoa. Where would be a place we would find this? The kidney tubules, good. Okay. All right, what about this one? Which one's stratified? Just yell it out. Stratified? Stratified. Yell it out. B, okay, good. All right, and then this one, which one's stratified? B again. Good. Okay, yeah, what's this one here? Pseudostratified what? Columnar epithelial tissue, yeah. Good. All right, guys, that's all we got. We're done early. Have a great rest of your day. We'll see you guys Wednesday.